Hello class, so this is part 2 of the solution. So let us try to look at one at a time. Inflection point, that means we are looking at double derivative. Let's look at the first derivative first. We end up getting 15 x to the fourth minus 40 x to the third. Now y double prime becomes, here we have 60 x to the third and then minus 120 x squared. If you have to break this one down, further we get 60 x squared becomes the common factor. We have x minus 2. Now here, you will get two candidates. We have one being 0, or one being 2, but you will realize that 0 is double root because of the square. Therefore, the sign will not change, the concavity will not change. But 2, since it's the linear single root, therefore it will change there, which makes our answer to be choice B. Alright, here, this is something that we already have done in class. I'm going to skip this one. Now let's look at number 19. We have absolute maximum. Now, when we are looking at absolute maximum, then we have to set the derivative equal to 0, derivative is not defined, meaning critical points, including the endpoints. Now, those are the things that we have to keep in our minds. Find the coordinate of absolute maximum, or k is fixed positive number. Then let's try to find the y prime first. Then what do we end up getting? Y prime becomes x times the derivative of this, which is negative k, e to the negative kx. Now, plus keeping e to the negative kx, derivative of x becomes simply 1. Now we realize that e to the negative kx is common. We have negative kx plus 1. When you try to set, since this will never be equal to 0, only thing that's possible is this one being equal to 0, then we get to realize that this negative kx plus 1 will equal to 0 if x is equal to 1 over k. Now x has to be equal to 1 over k. That gives us this one and this one. Now when x equals negative k, let's see if that will be the absolute maximum. You will realize that 1 over k, because this will always be positive, and when the values are less than 1 over k, then this becomes smaller, therefore it becomes positive. And when the value is greater than 1 over k, then this becomes greater than 1, hence becomes negative. Therefore, no wonder it becomes the maximum right here. Now, when you plug in 1 over k to the original function, then y becomes 1 over k times e to the negative k times 1 over k. Now, which gives us the result of e to the negative 1, that means 1 over ke. So therefore, our answer becomes choice A. Alright, let's move on. Here we have first derivative is positive, second derivative is negative, then we're going to go for the second derivative first. This means second derivative is negative, but first derivative has to be positive. That means we are looking at increasing sections, so therefore we are looking at something like this. Choice B seems to be our answer, therefore. Alright, trapezoidal rule, since we didn't do this one, we get to skip this one for now. And let's move on to the second one, or the one after. Here we have decreasing and concave up. That means the second derivative has to be positive, while first derivative is negative. So let us try to get the first derivative first. F prime now becomes 12x squared minus 42x and then plus 36. Now, f On the other hand, double prime becomes 24x minus 42. That's it. Now, when you factor this one carefully, we will realize that the common factor is 6. So we get 2x squared minus 7x, and here becomes plus 6. Now, the bottom one, and then in this case, when we're trying to factor this one, this will be equal to 6 times 2x and x. And since this is negative, we gotta have negative 2 here and negative 3 here. Then we would have factored it. Then looking into this one, we get to realize, I'm gonna move down a little bit. So based upon our number line, the two values are 2 here based upon the first derivative. Here the other one becomes 3 over 2. So 3 over 2, let us say, will be around here. Now, on the other hand, here, since if you set this one equal to 0, then we get 24x will be equal to 42, where x will be equal to 42 divided by 24. Now, when you simplify by canceling our 6's in top and bottom, we will end up getting 7 over 4. So 7 over 4 is in fact greater than 3 over 2. I'm going to put it right over here. Now, based upon this one, since the slope is positive, what's going to be happening is this. In terms of the second derivative, this portion will be negative, and this portion will be positive. On the other hand, in terms of the first derivative, since this graph would have been concave up, so it's going to be something like this. That means this is negative, this is positive, this is negative. Based upon what we already have done, first derivative has to be negative. That means we are looking at these sections. And second derivative has to be positive. That means our designated area would have been right over here. And the values of x are greater than 2. So when do I have value of x that's being greater than? Oops, oh my bad. I think I mixed those two things up. I'm sorry. Positive here, negative here, positive here. So in fact, our answer becomes, sorry about that. Once again, negative and positive. That means we are looking at right here. Value of x has to be greater than 7 over 4, but less than 2. So that becomes our final answer. Alright, let's move on. This is the formula. When t goes from 1 to 5, at the instant when the acceleration is 0. Acceleration has to be equal to 0 first. Then let's set that up. Acceleration is double derivative, so therefore we're going to get the first derivative first. Then this becomes 1 over t over there, and this becomes plus 2t over 18, and then which is equal to 1 over t plus t over 9. Now, double derivative, second derivative becomes here negative 1 over t squared plus 1 over 9. Now, when you set this one equal to 0, then we can easily see that t has to be equal to 3. When t is equal to 3, let's try to find the velocity. Then we get x prime of 3 now becomes 1 over 3 plus 3 over 9, which is also equal to 1 over 3. Therefore, our final answer becomes 2/3, which is choice C. Alright, now here, in this case, do you see to use the cosine and then sine, where one of them, if we set one of them equal to u, the other one becomes du. So let us say, now, let u equal to cosine of x. Because if we set u equal to cosine of x instead of sine, then we get to see its derivative right over there. And du here now becomes negative sine of x dx. So let's see if we have everything. Since we don't have negative in this case, I'm just going to bring that over. Then we get to realize negative du is equal to sine of x dx. Now, by using these substitutions, we end up getting integral of 6. And sine and then dx becomes negative du, while cosine becomes u, so we have u squared. So in other words, we get negative 6 integral of u squared du. That is a simplified form. If we take the antiderivative, negative 6, and then this becomes u cubed over 3 plus c. By plugging in cosine back on here, we end up getting, our final answer is negative 6 cosine cube x over 3 plus c. Here we get, so we have 2. So negative 2. It looks like choice D becomes our answer. Right, the next question, which will follow? The graph here is a second derivative, alright? Now, the graph of f has inflection point at x equals negative 1. When x equals negative 1, we see this one. Point of inflection has to be change in concavity, and then change of concavity in the second derivative becomes positive to negative. We see that change, so this one is okay. Now, the graph of f has concave down from negative 1 to 3. Yes, that's also okay, because concave down on second derivative means negative. Now, the graph of derivative of the function f, a derivative function f of f prime is increasing. So this one, f prime is increasing at x equals 1. X equals 1, we realize that the f double prime is negative. That means derivative of f prime is negative. That means instead of increasing, it should decrease. So therefore, our answer will be 1 and 2 only. That is it for now. So we're gonna have third video very soon.